Alright, it's time again for some Unity development. Let's get it going. We're just following the Catlike coding here, and just to learn how that stuff even works. So last episode we were doing, can I not have this all, but we were just doing a simple procedural mesh, an advanced multi-stream procedural mesh, and we found out that the advanced multi-stream procedural mesh is hell of a complicated. Seems like we're hacking the Unity engine itself, but this is all part of the engine. It's just dug in really deep. But the simple procedural mesh, well, Unity mesh is just vertices, triangles, normals, UV, tangents, all these all this information, and then you can have a mesh. But to be more effective and efficient, you gotta do something more complicated. I'm not going to pretend I know what is happening here, so I'm just following along the Catlike encoding tutorial and hope that we can somehow get familiar with the procedures. It's quite fitting that the Minecraft music is playing, because I firmly believe that if you follow this guy's tutorial here, the Catlike coding guy, what a genius, if you follow his tutorials especially on the meshes in Unity, you're going to have a great time making a Minecraft-like game. Voxel game, maybe give it your own twist, and maybe even have a proper game. Minecraft is fantastic, but it is more of a simulation than a game. Some things are missing to call this a game. But let's see. Can we continue on and see what is next? So it is an advanced single stream procedural mesh. Good. So let's just read this guy. Although we could define the attributes in any order, Unity requires a fixed attribute order per stream. Position, normal, tangent, color, texture coordinate sets from 0 up to 7, blend weights, and blend indices. Yep. So we're packing the mesh information into a stream, I think, is what we're doing, as opposed to just using the mesh data itself here in the mesh class, in the Unity mesh class. So how are we doing this? Mesh data, I think we defined, no? Oh yeah. So the mesh itself has a mesh data. Unity class, mesh data class, but we could make our own. And the mesh class also has a mesh data array, which we're also gonna manipulate ourselves. And then we're gonna put it together again in the end. Probably. Good. Which approach does a simple mesh API use? It uses a single stream, even though the data is provided via separate arrays. So it requires an additional conversion step to interleave or isolate the data. Good. Are we going to skip that step, or? We'll demonstrate the single stream approach by introducing an advanced single stream procedural mesh component type that's initially a copy of advanced multi-stream procedural mesh, with only its name changed. Alright. Adjust the scene like we did earlier so we can see the result of this new approach. Sure. Whatever you say, Catlike. Whatever you say. Good. So we have an advanced mesh, and don't tell me I have to hack the start again. I don't want to do this. Main camera, universal additional camera data. Scripts. We're gonna write our own script now, and that is going to be the God object script. God object. Good. So why am I doing it? And I'm gonna slap it into the camera. Why am I gonna do this? Because as a noob coder, you will probably just put everything in one script, and then you have a God object, and that's responsible for everything, and you don't know where anything is. And within the script, there's gonna be spaghetti, but depending on the size of your project, I don't know, you're gonna get spaghetti anyhow. This is just try to stay organized as best as you can, and this is all anybody can ask from you. All right, so the God object, good, is going to have an this here, and we're gonna see if this works. Good, God object, and we're gonna have it in the start. Let's be right in our own start. Here, I want it to be represented by our own style of writing code. Good. If you're watching this and you learn how to code, and you learn this for a company or in school, you're gonna get into trouble doing it the way I do it. You're not supposed to get your own style of coding. You're supposed to do the brackets like that, because it's easily readable for an outsider. Good, but I find this more beautiful, and I am an insider, so I don't know. This is just what I like. So I'm gonna have it like that. So is the start good enough to get rid of the singleton that the core RP library package introduced into Unity? Because I do not like singletons. I despise them. Huh, this looks good. This looks fantastic. Right, advanced mesh. But nope. Can we get rid of it? Absolutely, by removing the component. Good, and we're gonna call it not advanced mesh. So what do you want from me, Catlike? You want to demonstrate the single stream approach. Good to see you, Fat Cat. Fat Cat is chiming in there saying, Catlike coding, the more you learn, the more you'll be perfect. That is right. That is the hopes there. Advanced single stream. So we're gonna call this
nothing to report.
Single stream. There's nothing to report, Fat Cat? Is your life boring? Boring is good. Boring is fantastic. If you're believing the Hitman's Bodyguard, and I do. Single stream. Boring is you, Fat Cat? I don't know. I find it quite riveting every time you chime in there, especially during the Hitman streams. I was able to go swimming yesterday. Hey, that's good news. That's not nothing to report. Swimming is the number one fitness activity. Fitness activity number one is what I call the swimming. Good, God object, and we're done with the God object. We're never gonna look into it again, because we're doing the Catlike tutorials here. So what do we need? An advanced single stream procedural mesh. Oh, that's a mouthful. I think we can simply copy and paste here. That's commendable, Fat Cat. Going swimming. Really cool. Was it in a lake? Was it in a pool? Advanced single stream procedural mesh. Bum 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 bum. Good. I think we will not need this. This is just the Catlike showing off, but we're gonna humor them. Right. What do we need? A struct? Sure. A struct is a good thing. Let's put it in. Into the class. Struct vertex. Why is it called vertex? It is what it is. Good. Because this data gets copied directly to the mesh and to GPU memory without modification, it is essential that this data structure is used exactly as we describe it. Sure. Faka says, at the city pool, they had a winding slide, which was really fun. I got a lot of good exercise going up the stairs a million times. Faka says, don't worry, I kept my shirt on to save everyone emotional damage. Oh man. That's what I like about the fat cat. The fat cat is a civilized person. They feel shame. So many people don't feel shame. But the fat cat does. Because he has a soul. And that is what I equate. People that don't feel shame, they don't have a soul. Just kill them off. Honestly. Don't care about these people. And it's not a race-dependent thing. A lot of people are like, wow, this race and that race. No, it has nothing to do with that. For soul. So you have a soul or you don't. And it has nothing to do with what nationality or what skin color. And there are many people without a soul, unfortunately. Kill them off! I'm calling for violence here. And I can't, because there's no way to know who's got a soul or not. So if you know, then tell me. Good, or don't. Just go killing. I gotta stop saying that. People will do it. With all my giant fan base. Anyway, because this data gets covered, this isn't guaranteed by default, because a C# compiler might rearrange things in an effort to optimize our code. We can enforce the exact order by attaching the struct layout attribute to it with a layout kind sequential argument. Both are from the system runtime interrupt service namespace. Faka says, I've got to take my poor soul to church, so we'll catch you next time. Always great to see you. Fakat, always great to see you. Have fun in church. And no phone in church, man. Also, tonight is going to be time for the Eternal card game. Hope to see you there. So, have a good one. So both are from system runtime interest. Oh, this is a complicated usage here. System runtime interrupt services. Yeah, never heard of that. But that's why we're doing the Catlike coding. We want to learn. We want to learn. Require component of dot. The heck? Is that a thing or? Where do we put it? Below the struct or require component? No. This is here. This is there. Struct layout consequential struct vertex. Oh. Aha, I understand. It goes here. And then we have this there. Yup. Absolutely. Good. Anything else? So we require mesh render again. Good. In the future it's gonna have a collider as well, probably. But let's see how this looks. Struct layout kind sequential. Alright. To put all attributes in the first stream, we can simply remove the stream argument from all vertex attribute descriptor constructor invocations. What do you mean? Bum bum. Sleepy time there. Vertex attribute descriptor constructor invocations. What do you mean? I thought I would just... Oh, you want me to copy this now? You want me to copy all? Don't know. Next, remove the code that says separate streams. I think they want me to copy everything. Sure. Oh, not that. This is a bunch. Are we using the math? I have questions. But alright, let's put this in. Good. So what do you want me to do? Vertex attribute 0, 1 and so on. Dimension 3. Sure. So we don't need the stream there, you say? Alright. Then not. Good. And here one of the thingies is telling them where to put this. Where to put the stuff. Into stream 2 and 3. Man, I don't see what's going on here. Good. Wall of code. Next, remove the code that says the separate streams. Vertex attributes dispose. Tangents, triangles. Mesh data, set index buffer. Submesh count. So this is where we're setting the triangle. So above we have stream information apparently. Vertex attributes dispose. Where? Do we have this? Oh. Is this here? Yeah, we have it. We do have it. Vertices, tangents. Native array floats. Get vertex data float 3. We don't need. Why is there so many here? Oh, come on. They're hidden. Alright. The native array. We have to get rid of everywhere. Sure. Native array. Native array. Native array. Native array. Sure, no problem. 1, 2, 3, 4. Native array. And now we have to fix it. Native array vertex vertices mesh to get vertex set of vertex from the vertex class we wrote here. Good, and where do we put it? Above the index buffer params. Above the triangle data, just like that? Set index buffer, native array u short. This has nothing to do with triangles. Damn it. But it's fine. Good, let's just put it in here then. It's alright. Finally, set the same vertices again. Oh, alright. But now by assigning complete vertices to a single array. As they all have the same normal and tangent, we can set those once, only changing position and texture coordinates per vertex. Good. Oh, alright. Sure, mission triangle. So this is just put in here. Okay, this is less typing now. More copying, pasting. But we will go over the code so we see what we did. Good. So we have a variable that is a vertex. That's a new vertex. Good. What kind of variable? Unity has to figure it out itself. If you put in vertex, it will know as well, but then it says vertex. It's alright. A vertex position, vertex text coordinates, vertices. Tangent, normal, back. So what is this vertex structure? Is a float 3 position. And it's a float 3 normal. So we have 4 properties of this vertex structure. It's a float 3 position. It's normal. Also float 3. So that's 2 vectors here. Good. But flow 3 vectors. Then we have a very small number here. It's tangent, and then we have a very small number here. Have to, I'm still not, is this some float variant? Text coordinates. Have 4 tangent. No, I think this is 4-dimensional and this is 2-dimensional. Tangent 4-dimensional and a 2-dimensional text coordinate. So this is not a float 4, but it's a half 4. Whatever that means. Good. But it's definitely 2-dimensional. This is 4 floats, and this is 2 floats, and this is 3 floats. That's what I'm thinking. But the advantage of using half 2 and not float 2 or vector 2 is that it takes up less space. Fewer bytes, probably. That's what I'm thinking. Correct me if I'm wrong. Or don't. Find it out for yourself. This is for learning. But if you can correct me, you can. All right, what is this here? Let's go further down. What did we just paste in here? This is not my code style. Mesh data sets up mesh new devs during bounds. Oh yeah, we're setting a submesh here from the mesh data. That's all right. Then we got a new mesh, advanced process. And we will call it simply advanced. Oh, oops. Simply advanced. Good. All right. But we were not done reading the rest. Vertex position, vertex 6 coordinate. Position is 0f. Text coordinate 0. Why do you have a property like this? Text coordinate, where is this? Where is this coming from? I don't see. Oh, here it is. Ha! Good, of course. That makes sense. Position, text coordinate. Good, and then vertices 1. I'm gonna add the vertex. Good. Vertices 2, we're gonna add the vertices here. Alright, alright. Good, good. In our vertex array that makes up the mesh. Good. Then we have the triangles as normal. And then we have the bounds. Good. And then we're counting the submeshes. Why is this double though? Is it double here? Surely I made a mistake here. This is extremely dry. This is super duper dry. Because it's a carbon copy. Mesh data set. I think we're good over here. Right. The result appears exactly the same as the multi-stream approach. Even the mesh inspector shows no difference, but the data layout is different. Is it possible to use a mixed stream approach? Yeah, that's what I was asking. Yes, you could, for example, put all positions in the first stream and group the other data in the second stream. Such a layout could be beneficial for GPU caching, improving performance for depth only and shadow caster passes. However, if such passes require other data, for example texture coordinates for alpha testing, then this benefit would be lost. Good, let's check it out in Unity. See if we made a mistake. 110. What's your problem in 110? Oh, we're at the end, but we're not. Sure. Float 3 could not be found. Oh dear. We don't know what a float 3 is. Well, let's teach ourselves some math. Good, and why is this using static Unity method? This is just crazy pants. But let's put it in. Need some math here. Good, flow 3 can still not be found. What? Why not? Collections, mathematics. Mathematics. Mathematics are important. You need to learn how to count. Oh, what the hell? Native is not found. Why? Did we not need to get rid of this? At some point? Or are we missing something still? Let's find out. Single stream approach. Advanced single stream. That we do. Interrupt services. Layout kind sequential. Vertices. Native array. Vertex. This is a lot. Script updated for library B artifacts. What the hell? Submesh descriptor could not be found. Completely stumped again. Mesh data, here you don't have that problem. Collection, mathematic, engine, rendering. Collection, we don't have rendering here. That is quite important. Still not. Still not. Collection, mathematic, engine, rendering. I don't know. Japanese native array could not be found in 28. But here we have the native array. No problem. Alright. Single stream. Can we not have this? No, we cannot. I want to know what is the problem. God. Expected, yeah. Sure. Huh? What? Commented everything out. How do you find it now? Advanced single stream. Advanced multi-stream procedure. Ugh! I commented out the... But I think... Got something here? No. Dum dum. Commented out the wrong thing. Alright. Good, so it's working fine. As you can see. Or not. What? Have I still commented it out? Yep. Da 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 da. Good, so we're going again. It is down there, good. Alright. Let's move it out a little bit. Have the simple run as well. Alright. But they don't like here the advanced something. Native array. Weird. Why is it here not alright, but here it is alright? What difference does this make? I don't get it. Let's look at the error message again. But that will not help me. Public class. Native array. Here you do not know what a native array is. And here you do. And yet we're using all these. Unity collections, Unity mathematics, Unity collections. Unity mathematics. Unity engine rendering. Unity engine rendering. System collections generic. Static Unity math. And then you have generic collections and the interrupt services. Does it matter in which one order? Probably not. Don't like the native array, why? Typo namespace native array could not be found. In line 29. Native array. What about here, the line 29? It's line 19, but alright. Here it's alright. Vertex attribute descriptor. Oof, what am I missing? Somebody help. Native array. You don't like here, but you do like there. What are we doing different? I don't get it. Maybe just add in the collections then. Oh, wait a minute. No. They are a bonus. I don't think they need it. Good question. System collections generic. What if they're not there? Still not. We could just continue with the next tutorial and call this a fail. Because I have no idea what is happening. Tangents does not exist. 950. Maybe I haven't copied something. Wait a minute. But it did copy everything. Did copy everything. The whole class. No idea. Using directive assembly reference. No, I'm not. I'm not missing. Advanced single stream procedural mesh. Up here. Vertex attributes. This is fishy anyhow because if I don't have this var, it's not gonna work. New native array. Damn it. Why is this not working? What is the problem? Let's get rid of the vertex struct. Sequential layout. Still you have that problem. In top service. Still you have that problem. Let's get rid of everything but the native array stuff. You don't know what a native array is? Why not? What's the difference from here to there? Oh, wait a minute, what? System collections? And here's Unity collections. Dum, dum, dum. Oh man, I don't know. Unity math? What did I do here? 1, 2, 3 things I got rid of. Unity collections instead of system collections. And that will make it work. No? Name positions does not exist. Does not exist. 39. Alright. Good, this is where we started testing. So let's make a save point here. Good. Then we're gonna say Unity collections. Good. And now things are not existing. 40 positions. Does not exist. Where is my positions here? Native array float 3. Yeah, but they told us to get rid of it. And they told us to put it in again. Probably in the wrong space then. Good, yeah, positions does not exist. Mesh data. Mesh data. Nope, it does not exist here at all. Positions equal. So much for that. Did they tell us how to do it? Good position, but hey! Here are some positions now. Structure layout sequential. We have this. Good, we remove that. There are some vertices. Vertex position. Oh. This looks like we have to get rid of this here completely simply. We don't have this anymore, do we? Because we have the vertex defined. Good. Finally set the same vertex numbers and complete vertex is a single array. See, all this you can set those once, only changing position texture counts per vertex. Alright, so we don't need the saw. Oh, what did I press there? What button? Oh, that's not a good button to press. Oh, here we are again, good. Normals? We do not have either. Tangents we don't have. UV we don't have. Alright, where are we? Here. Native array, vertices, mesh data. Vertices 0. Good. Then we make the vertex. Triangles. We probably don't have either then. Do we? I don't know. Oh, this is a lot of guesswork. It's an extreme amount of guesswork. Advanced mesh, no. Single mesh, come up to the front. Simple, no. Does not work. Because we don't have the script attached. Can't believe this is working. For some reason, this is extremely working now. Good. I'm glad. We can move on to the next tutorial. But, so which one are we doing now? The simple procedural mesh, the advanced multi-stream procedural mesh, or the advanced single-stream procedural mesh? Catlike. Catlike is not there to help me out. That's alright. The fat cat doesn't know. But, the Catlike would. They wrote the tutorial. Alright. Next tutorial is square grid. Maybe they're gonna just continue on and tell us what to do. Oh dear. 3 times 3. Good. Design a generic mesh job framework. Define separate mesh streams and generators. Disable restrictions on native container access. Create a grid of squads on the XZ plane. Generate rows of squads instead of individual quads. This is the second tutorial in the series about procedural meshes. The previous tutorial introduced the advanced mesh API. This time we'll use that API to make a burst job that generates a square grid consisting of multiple quads. Good. Fantastic. A square grid is only one of many procedural meshes that we could generate. So instead of starting directly with a square grid job, we'll first design a framework that supports a general approach. This works somewhat similar to the generic approach that we used in a pseudo-random noise series, but with a few differences. Oh, we haven't played that one, but we might. Generic vertex. First thing that we'll do is define a generic vertex struct type to hold the vertex data. Hey, that sounds familiar. That's what we did here. Good. Let's put its asset file in the scripts procedural meshes subfolder. Oh, we have a procedural meshes subfolder now? It's funny, procedural. Well, everything is a procedure. So I don't like the terminology there. In this case, it's a certain procedure to make the mesh. That's good. But creating a dungeon procedural, everybody's expecting a roguelike dungeon. That's completely random, and that doesn't make any sense to me. So we're gonna go with Catlike, and we're gonna oblige them. Procedural meshes, right? This is a subfolder. Procedural meshes. Good. Give me those and put them in. Bzzzt. Alright. Boom, 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 boom. Asset file in scripts procedural meshes subfolder. We call it vertex. Good, except that we won't bother with minimizing its size. So give everything the appropriate flow type. Oh, we want this to be big? All of a sudden? So what happens if I call the same name? Unity might say, wait a minute, you have two different types of vertex structs. Let's see. Give this an editor? No. No. And no. Good. What the heck is this? Some noob wrote this. Terrible. That's actually great code. I wrote this, by the way. Good. What did you want from me? A vertex for something? Vertex is what we're going to call the new script, and we're going to open it up. Good. And you want this to be exactly like the other one. Good. Using Unity. Dun, 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 dun. Mathematics. Because we need those math. Public struct vertex. Boom, 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 boom. Should we leave this in? For kicks? Why not? Good, we have a public struct that is a vertex. And... oh, let's make it look like that. Is there not a better way to stylize this? Because this is a struct. I think I'm going to do something. Oops. Like delete it. Do something different. So it looks different. To signify that this is something different from a method. Good, we have a struct and this is how it looks. And I'm not really a fan. Yeah, let's have a real fat code block here. And that is cool. Alright, in the pseudo-random noise series, we put all noise-related types in a single class and used partial classes to split the code into multiple files. Partial classes to split the code into multiple files. Why would you spaghetti up your code like that? This time we'll use a different approach. A custom namespace. No! No, not a namespace. Oh. No. Which wheel named procedural meshes. He knows that it's a bad idea, that's why he made that typo there. To make a type part of a namespace, it has to be defined inside a namespace block with the appropriate name as if it were nested inside a class block. Do this for vertex. No. I don't want this. I don't like namespaces. For what? You put all other procedural meshes type assets in the procedural meshes folder as well. Mesh streams. Ugh, this sucks. So now Unity will complain, but if we put in this vertex in a namespace, then Unity will not complain. That's what I'm thinking. Does it not complain either way? No, I haven't saved yet. Let's save. Yep. Vertex number name is going to be the same name. You have to use a namespace. So the only advantage a namespace has is that you can name two things the same name. Why would you do this? There are a million names. Just have a new name. Just call it V or something, or VX or VTX. Something, anything, and name it there in the other thing that is barely used. God, I hate this. For the sake of learning Unity, we're going to do this, but it really sucks. So when we're done with the learning here, we are going to use what we learned to make a voxel game, but definitely gonna get rid of all namespace. That sounds like bulk. That looks like bulk to me. It's just too much and doesn't do anything really. It's just wasted space. It should be called wasted space, not namespace. But let's do it. God, this sucks. Anyway, namespace, procedural, and then a big name as well. Meshes, and then encapsulate. Oh man. And we don't have a class then? This is not a class, or what? So we don't have an... Oh, wait. Maybe this is instead of a class, and then it's all fine. And I complained for nothing. I don't know. Good, so it's not a class. And let's get rid of the code now. Oh yeah. Ugh. Delete me. Good. Is this wrong again? Surely. Alright, good. It's not a class. It just uses math. And we should be good here. Let's check it out in Unity. Good. Alright, Catlike. If you put in a class, and now I'm gonna cry. Put all of the types of procedural meshes folder as well. All other procedural meshes type assets. Yeah, alright. Mesh streams. To store the mesh data, we need to define the vertex and index buffers and copy the relevant data in the appropriate format. Rather than define this explicitly for each job, we'll isolate this code by introducing a procedural meshes iMeshStreams interface. It will take care of setting up the vertex and index buffers, hiding the details of how many streams there are and what the exact data format is. Yeah, hide it. Good. procedural meshes. Namespace, procedural meshes. Public interface, iMesh streams, mathematics. So we have a new thing. But what would it be called? This here is called Vertex. And Unity does not have a problem with that. Vertex structure. Let's put its asset. File description as a mesh subfolder. Good. Vertex is presumed subfolder. Constants are the same as constants are the same as advanced instant procedure mesh vertex, except that we won't bother minimizing size to give you the appropriate flow type. Good. So we put it in a single class and use partial. This time we use a different approach. Custom namespace which we name procedural meshes. To make a partial namespace, it has to be defined with the appropriate name is written inside a class block. Do this for vertex. Good. We'll put all other procedural meshes type assets in the right. Mesh streams. To store the mesh data, we need to define the vertex and index buffers and copy the relevant data in the appropriate format. Rather than define this explicit for each, we'll isolate this by introducing procedural iMesh streams interface. We'll take care of procedural buffer setting exact data as this. Its first responsibility. Yeah, but what is it called? Let's call it iMesh streams then. Good. Create C# script iMesh streams. Bam, bomb, beta, bomb, beam, bomb. Good. And this is going to look exactly like that, except not. It needs more. It needs the Unity engine apparently. Good. Beam bomb, beam bomb. And then it's going to be a public interface. Sure. Why not? Yeah. iMesh streams. So that's I don't know what it does. Normally this is like a property, but not like a coding property. It's a property of a game object in Unity, but not like a property. It's like something you can do, like an ability, right? So you put the I bleedable on a character, and then you use an interface to then have an easier time somehow coding. But is this the same? I don't know. We're gonna find out. Next is the public interface iMesh streams. Good. And this interface is having parentheses here. Its first responsibility is to initialize the mesh data. We define a setup method for this, with the mesh data as a parameter, along with the desired vertex count and index count. Good, we're gonna put this void in. Just here in the namespace? I don't know where to put this. Let's put it in the namespace then. No idea. It also takes a Alright, let's copy everything in. Because I don't know where this is going. Dun, dun. Alright, save it. Would that work? No, of course not. Namespace cannot directly do this. That's what I was thinking. Define a setup method for this. Mesh data is with it. But where? This single stream, in a single stream, has to be structured work with burst jobs. I completely Procedure meshes streams nested namespace. Procedure meshes streams. Feel like there is a step missing here somewhere. Do the swap vertex. We did. All other mesh type assets are procedure as well. Mesh streams, store mesh, namespace procedure, and public interface are mesh streams. None is desired for scheduling schedule. Don't know. Don't know what you want from me. This is not anything. It doesn't mean anything to me. To make a type part of a namespace, it has to be defined and send names to the appropriate name. I know. We put this procedure mesh type data in procedure mesh folder as well. Mesh stream. To store mesh data, we need to define the various index buffers in an appropriate format rather than define the for each job. We'll isolate the code by introducing a procedure mesh interface. Yeah. Public interface and mesh streams. Oh, wait a minute. This might be part of the interface. In the end. Oh, it is part of the interface. Man, nobody told me. Alright. Good, so we have that now. Good, I don't know what they want to do. Set triangle, set vertex, that all sounds familiar. It's probably good. The most straightforward implementation of this interface would be a single stream approach. We'll name this type single stream, and it has to be a structure to work with burst jobs. Streams. So was this named streams and not iMesh streams? Public struct single stream iMesh streams. No. But it is a different namespace. Oh, this is really complicated. Most stuck within the burst job. We also group the stream implementation and procedure streams nested namespace. I also put their assets in script procedure streams subfolder. Oh. If we must. This is complicating things. I really doubt that this really helps. If you code anything to make a folder and a folder and a subfolder and a little file and a little file and a little file, and in the end it's gonna be super big files. Hopefully not. Good, but what do we do here? Inside it seems a single stream. It's a single spare. Good, let's make a single stream then. Create C# script. Single stream. Good. Compile it and open. Right. Give me all this. Namespace procedure meshes. And we have a public struct that we're going to use. Good. Procedure stream. Our streams is namespace procedure meshes. Doesn't use as much. Got a public interface here. iMesh streams. And here we have just a struct that is inheriting everything from here. How is this not overly complicated? We're learning to code, right? Alright. Let's save this stuff. Good. Rendering system runtime compiler services. We need those, apparently. Good. System runtime interrupt services again. Good. Add the setup method. and use it to define the mesh buffers like we did in advanced things. Instead of use 32-bit floats everywhere. Also immediately set the single submesh, not yet worrying about its bounds. Let's have a setup inside this single stream. Good. Dum boom beam boom. Why do you have two indentions here? Shift backwards? No. Ugh. So if you select everything and you shift tab, there we go. Alright. How's this looking even? A nice descriptor here. Don't wrap me. Don't wrap me, game. I want to see what's going on. Dun, 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 dun. Just so I know what's what. And then we're going to have another line here. Mesh data set ready, descriptor, descriptor up. Set innings buffer params. Descriptor dispose. Mesh data. Set index, submesh count, set submesh. Variable descriptor. Looks familiar. It looks more concise. Good. To store the vertex data in a single stream, introduce a private nested stream 0 type. Sure. Also, we're going to see if we throw anything errors. Single stream does not implement interface. Does not implement interface member image stream set vertex. Heh? In the 10. What? Otherwise it's looking so funky. This is a struct. This must look different. But there's so much in it. So what's the error? Does not implement interface member image stream set vertex. Image stream set vertex? Yeah, so? Doesn't 10. Yeah, I don't see the problem. Set vertex, set triangle. Set vertex, set triangle. We don't have a getter setter here, but is that the problem? What does Catlike has to say to that? Must have using a stream, proceed using a stream to store the vertex data. It's a private necessary exactly matches picture. Well, they don't want. It's fine. It's fine. The Catlike don't want us to run this. Catlike wants us to run this when we're all the way down here. Not before. So I guess we have to work on some other files beforehand. Good, so this is the last thing we did. And if I could... no, let's leave it be. Don't like this, but it's fine. To store the vertex data in single stream, which is a private nested stream 0 type. Good, but where? Here again? It exactly matches the vertex, except that here we should make sure that the field order is fixed by attaching the struct layout consequential attribute to it. Use it to define a native array field for the stream and retrieve it at the end of setup. At the end of setup. Good, so on top of the setup, we're going to squish in this all. The stream 0 struct. Make sure it looks nice. Like a struct, not like the other struct. It's a struct within a struct. Genius. Good, and then stream 0 equals mesh data, get vertex data of the stream type 0. At the end of setup. Gonna put that in. Good. The implementation of set vertex then consists of copying set vertex. Isn't that what you were complaining about? Yeah. Good. The implementation of set vertex then consists of copying the vertex data to a stream 0 value and storing it at the appropriate index in the stream. Sure. Public void set vertex. Can't we just use vertex for the stream type? Yes. If you get vertex and split sequentially at however, this approach allows more flexibility data to vertex. For example, vertex color, without having to immediately just single stream. Keep in mind that burst will optimize away intermediate steps like copying from vertex to stream 0. Alright, so then there's nothing to worry about. Good. Public void set vertex. Copy. Good. But where to put this? Into the vertex? Into the image stream or into the single stream? Native array stream. What are you complaining about? iMesh streams you're complaining about. Set vertex. Void set vertex. Public void set vertex. So do we have to copy this over? Or are we overloading? Or are we putting this in here? That I don't know. It's trivia, but it could be a lot more complex. This is trivia? For example, if we decided to stop in such case the both might decide to include that subject only once and insert a call instruction, a method invocation, each time a vertex gets set. This approach is slow and prevents aggressive code optimizations. So we instruct burst to always insert the entire code in line instead of going for a call. This is done by attaching the method imp1 attribute to the method with the method impl, not imp1 options. Aggressive inlining is its argument. Step is part of the system runtime component source namespace. Should we always suggest aggressive inlining? As a rule of thumb, you could indeed always do this, but it mostly isn't necessary. Small methods are inlined automatically. Those that are used only one are also inlined. To be sure, inspect the code generated by bursts to see whether an desired call instruction are present. In our specific case, we'll invoke set vertex 4 times per quad. If we'd include code to convert from float to half in set vertex, then burst likely won't inline the method. At this point, set vertex doesn't require the attribute, but I include it as a demonstration. Finally, we can directly code the triangle data to the index buffer bunch. So the mesh generators. So I'm just assuming setting the vertex here is alright. Just assuming here. If they wouldn't set it here, they would go... Oh man. they would go here where we inherit from and do it there, because we cannot find it in here. That's what I'm thinking, but what do I know? Public void set vertex. Good, and then there is this that I don't understand. Stream index equals whatever. I cannot read this for the life of me. Let's see if it even works. Hey, we have a set vertex now. The modifier public is not valid for this item on 38, on the new item. That makes me think it must go somewhere else. Because Catlike said public here. Nope. Nope. Also, this doesn't look like a setter. And yet it says set, which is really annoying. So we're gonna put it here then, where they're supposed to be a setter. I don't get it. Type image already defines the memory code set vertex. 12. Huh? Oh yeah, we already have this, I know. So let's have a different one then. SyncStream does not implement interface member at set right. Good. It's weird because here is one. And you weren't complaining there. Let's keep going. This is just a little bit painful. Implementation of the thing consists of copying very distributed and strong. To appropriate, yep. That's what we just did. Our implementation of set vertex is trivial. It is not. Good. It is types of project in term compiler service. Set vertex, blah blah blah. Method implementation. Aggressive inlining on top of this. Just because I want to be aggressive here. Finally, we can directly copy the triangle data to the index buffer by reinterpreting the index data to int3 triangle data. Store the native array in a field at the end of setup and perform the copy in set triangle. Perform the copy in set triangle. We're going to perform the copy for sure. Good. Set native. Oh, here's a native array again. Oh joy. Public void setup. Native array in 3 triangles. And the triangles are down here. Above the stream 0. And we're going to set the triangle, of course, in a different way from before. Good. Isn't that fantastic? Equals triangle. Set triangle equals triangle. Triangles equals triangle. Doesn't look like we have this defined, but maybe this is because we have it here, and this is a very shorthand code here. I just recently read up on this. By accident I found out what this does, but of course I have completely forgotten again. This is like, I think you're skipping the method brackets here. Skipping the method brackets. I think. And give it a return automatically or something. I don't know. If you know, please tell me. No. Nobody knows. Maybe you can explain it in the comments. Or maybe you don't care. Good. Mesh generators. What is this? We'll also introduce an interface, but let's see what it does. It throws errors. Method implementation attribute could not be found. Method implementation options. Did you not warn me about this? Yep, it did. Bom, beam, bom, beam. So it just mentions it. It does not. So for a person just copying it over, they don't know what to do. Like the cobbler. All right. Oh, we expect a semicolon there. In the 3? Oh. Alright then. Why don't you do it for me, man? Alright. Oh, that would be terrible. Good. Could not be found again on a 13. This thing. I thought the compiler services would be great. But they completely are because we're using them. Nope. Stream is now a problem. Stream 0 does not exist. In the 14. Wait, what? It did not complain before I introduced this stuff. That's weird. Index, vertex. Set vertex. Stream 0 with an index. And set native array stream 0. This looks like we don't need to set it here. This now looks like we need to set it in the other mother. But we tried this. We tried this and it threw an error because here is stream 0. Maybe not inside the setup then. Name stream does not exist. 14 mesh I streams. But we just got rid of it. Oh, we did not save, sorry. Good. Triangles. That's what I thought. It never told me to go here even in the first place. Dum damn bomb. Oh. Oh. No. Can't see really what is happening. Public void, give me this. It's inside the setup. I don't want it inside the setup. What am I doing? Setup is fine. Set vertex. Set triangles. Good. Also the iMesh streams is fine. And now we're gonna make it aggressive. Also, what happens if I say, hey, I have this. I have this. Then of course the method here overrides as per inheritance. Single stream does not implement 10. The face of my memory streams at vertex. Cannot implement an interface member because it's not public. 10. What? It's not public, but it is. Set triangles? Oh, oops, sorry. My mistake. Alright, good. And since we're, as per inheritance rules, just overriding practically here, means we can have these, no problem. They're named the same, but they're not gonna get used. Probably. Good, and here we're definitely gonna make this very aggressive here. Aggressive inlining, good, because that's how we roll. Could be aggressive here. Put it there. Using this stuff. Oh, we're already using them. That's why they were just mentioned and not put in there. Good. Alright. Extremely beautiful. Aggressively beautiful. Can we just use the vertex? No. Do the rest. So finally we can directly copy the triangle data to the index buffer by reinterpreting the index data to int3 triangle data. So the native array in the field at the end of setup. At the end of setup. Like we did there. Good. And we do have a native array here. And then we're going to set the triangle. Perform the copy and set the triangle. At the end of the struct. Because that's what we like to do. We like to make structs and then put methods in them. Good. Because it's good to have, in this case, this is practically a class, right? The only difference is that if you have this struct, then you can make copies of that. And if you had a class, you would probably just only reference to it. So it's a good idea to make this a struct. Anyway, mesh generators. We'll also introduce an interface for the part of the code that takes care of generating the mesh, naming it Procedural Meshes iMesh Generator. It defines the code that gets executed by the job. So it needs an execute method with an index parameter. We also give it a second parameter for the streams used for storage. This has to be a generic parameter, constrained to be a struct, that implements iMesh streams. We don't need to make the entire interface generic. We can limit this to the execute method only. Ha! That's a relief. I have no idea what this is talking about, but let's make an iMesh generator. Alright. We'll put it in the streams or put it here? It doesn't matter, honestly. iMesh generator. Fantastic. What's the problem now? Wait, what? Single stream already defines a member called set triangle with the same parameter types. 51 on single stream. Oh yeah, we have it. But where did we need to put it? Here. So the set vertex is where? At the end of it, isn't it? Does it matter? I don't know. I really don't. Dum bum 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 here. Good. Problem solved. iMesh generator is what we're gonna mess about now with. Good. Procedure meshes iMesh generator. Good. And this is how it looks initially. Namespace, procedure, public interface, iMesh generator. Good. Public interface, iMesh generator in here. Public struct, single stream inheriting from iMesh streams. Man, I don't know. Good. We need to know the vertex count for the mesh that gets generated, and the generator can provide it via vertex count getter property. You can add it to the interface by writing int vertex count get. Also include a getter property for the index count. But where? At the end? Good. Oops. Oops. Let's type it all out. Manually. Never. Besides that, the length of the job must also be known when scheduling it. Add a job length getter property to provide this information. This is so advanced. Somebody else needs to do this, not me. I have no idea what this is all. Good. Job length get. Wonderful. To generate our square grid, we have to implement this interface. By defining the procedure measure generated square grid struct type, once again in a nested namespace and a separate subfolder. Square grid. Generators. And now they lost me. Completely lost me. Streams. Generators. iMesh generator. Good. Create C# script iMesh generator. Did we not just make this? Yeah, we did this. But it inherits from that. It's different. It's called square grid. Is it? To generate a square grid, we have to implement the interface by defining the procedure to square grid struct type. Good. Square grid. Alright, it's gonna complain. No? Separate subfolder. Because we don't have enough folders yet. Alright. iMesh generator public int. We won't generate the grid just yet. Focus on completing the framework first. So for now, only provide a minimal implementation that generates an empty mesh and does nothing. Fantastic. Public int. Good. Sure. Why not? This must be behind the generator. I'm not sure. Good, we have the mathematics. Are we using the static? We have the generators. We open the bracket. Put in the public struct. That is empty, and then afterwards we put in this. Probably, I don't know. Namespace cannot directly contain members. So that then sounds like We have to put it inside here, of course. Of course. How could I? Oh, how am I doing this? Cool. Hey, nice feature. Shift and control holding moves things. That's pretty cool. Alright. That then. Alright, we did what you asked of us, Catlike. What now? Mesh job. The next step is to define a burst job to generate meshes, for which we introduce the procedure meshes mesh job type. This is a generic iJob4 struct with type parameters for iMesh generator and iMesh streams. Good. So what do you want? We want a mesh job. Good. And where do we put it? In which of these fantastic folders? It is a mesh job. Sounds like we're generating something, right? Create a C# script. Mesh job. Good. And this is super duper complicated. I will not even pretend to understand any of this. Good. Precision burst compile, float position standard, float mode fast, compile synchronously is true. These are just arguments here for the burst compile. That is going to happen when we instantiate the struct. That's not the right word. But when we make this struct happen. Maybe when we set it? I don't know. When we invoke it? No, it's also wrong. Oh, whatever. When we make it. When we make it happen. Give it private fields for the generator and streams. Its execute method simply forwards the invocation to the generator, passing it both the index and streams. Good. Of course. Generator. Generator as streams. Good. iMesh streams with G as struct. Generated by S struct iMesh streams. Generator streams. Ridiculous. Just ridiculous. Because we're only writing to the streams when generating the mesh and don't read from them, we can attach a write-only attribute to the streams. This will indirectly apply the write-only state to the native arrays contained by the iMesh streams implementation. I'm doing it, but why? Like we did in the pseudo-random noise series, we also give this job its own public state schedule parallel method that creates and schedules the job, returning its job handle. It needs mesh data and a job dependency as parameters. In this case, we have to invoke setup on the job streams before scheduling, passing it the mesh data along with the vertex and index counts that we retrieve from the jobs generator. Public static job handle schedule parallel. Good. And it goes in here somewhere. Like maybe here. Good. This is weird again. Good, so you do this. Job handle parallel. You're doing this all. Public static, good. Oh, this should be inside there, shouldn't it? Good, then you give me this all. And then you return the job. which is a new mesh job, which is this up there, the struct. Good. It's a variable. It's a variable, you go figure. Good, and here this is done. Let's see if Unity complains, of course. Namespace cannot directly contain. Does it? So sorry about that then. Is it inside the struct? So it returns itself? What? It's making itself inside itself. Perverted stuff. But is that really the case, or did I mess something up? This is the namespace. Means it has to go in here. Perverted stuff. Perverted stuff. Procedural mesh component. To try out our framework, I would love to try it out. We'll create a procedural mesh component type that will set the mesh of its mesh filter component, like the components of the previous tutorial. This type isn't part of the framework itself, so we'll put its asset in the scripts folder. Also, as it isn't part of our namespaces, we'll have to import them all. Good. So what we're doing, a procedural mesh simply, apparently. Alright. We do a procedural mesh in our scripts. Procedural meshes. God object. Why not here? Procedural meshes and procedural mesh. Advanced multi, advanced single stream, simple procedural mesh. And now we have a procedural mesh. But they want it in a scripts folder, so we're going to put it there. Maybe because it's just for testing out, or why am I doing this? Good, put it in. Make it fappen. Good, we have procedural meshes. We have procedural meshes generators. We have procedural meshes streams. Generators and streams. Now, I'm wondering if it's important where I put the stuff. Generators and streams. iMesh generator, iMesh streams. Should this not be there? Maybe. Streams. Good. Here we have a vertex that we're not using. I hope this works. I really do. Good. The Catlike is telling us this time we'll create the mesh object in the awake method, generate the mesh, and assign it to the mesh filter. We put the mesh generating code in a separate generate mesh method and keep track of the mesh via a field. That sounds easy. Good, let's put it in. There is no namespace here, but there is the class. We have a mesh. And do we need this? Maybe we can call it variable mesh to avoid the duplication there, but Catlike is doing it now, so we're doing it as well. Good, so in the awake method, let's read this. We have a mesh, a new mesh. Good. We're also going to name it procedural mesh, like we did the simple mesh. We're just gonna name it mesh now. Good. We generate the mesh, and we get the component mesh filter. Mesh and assign it, and then we generate the mesh. Easy peasy. Generating the mesh consists of allocating writable mesh data, followed by scheduling and immediately completing a mesh job for it, using our square grid and single stream types, and then applying it to the mesh. So when we generate the mesh, we do this all. Good. And then we finally have a thing we can test out in the editor. Good, single stream. Simple procedural mesh script. Is that what we're using? What about procedural mesh? Let's see what the Catlike array. Now create a procedural mesh game object, either in a new scene or replacing this as a quad generating game object of a previous tutorial. Good, we have an advanced and a single stream. We're gonna all nope, and we're also going to duplicate this and put it up front, and we are also going to rename this into proc, and then we're going to get rid of that, and we're going to say procedural mesh instead. Right, to test it out. Also, I want this enabled, and we got nothing. Oh, we do have something. This is the script, sure. And it should have given me a mesh, and it did. And there it is. Let's see what the Catlike says. Procedural mesh, or mesh for short. Transform, no mesh filter, mesh renderer. So it did give me one. And it's empty, of course. Good. Says none. We hit play, and there it is. Wonderful. But let this be all for today. Next time we're going to continue on with this. And just to recap, this is all needed for a game. If you want to make a voxel game, then I highly recommend learning this all from the Catlike, like I'm trying to do. Currently I'm a little bit lost, but we're just copy pasting everything in, and we're doing all the thingies there. Wait, what? Did we? Still working? Yes. And we're just copying over the tutorial and trying to understand as best as we can what is happening. And this is all we can do to learn this. And if we haven't learned it by the first time, we've got to do it again and again, simply. Like that. And finally, we're going to give it our own twist by making a voxel game from that. And the Catlike coding, there's a lot of tutorials. Surely we're going to learn a lot from this. And hopefully be able to make a voxel game then. Good. Thank you guys so much for watching. Until next time, don't forget my free spin giveaway on the 1st of every month. And leave a comment if, like me, you have questions. Or rather, leave a comment if, unlike me, you know what is going on and can maybe explain some things. Like, we're a little bit lost here. Or most people will be just following this tutorial, being complete noobs like I am. But the first one we got, anyways. Doesn't matter. See you next time. Have a good day and a good night.